Alright, let's see if I'm recording here. Um, we have this function. They're asking us for the period, amplitude, center line, and so forth. So the period is 2 for cosine, sine, secant, cosecant is 2 pi. So we want to take 2 pi divided by the coefficient. So that's 2. The amplitude, we want it to be positive because the period and amplitude are distances. So I try to stress taking the absolute value. The center line is the vertical shift of the graph. Normally cosine has a center line of y equals 0, but with the vertical shift up 3 units, the center line will be at 3. Your basic cosine graph is between 1 and negative 1 and has this general shape. It starts at 0, 1. These points are equally spaced apart. So we cross the center line when the input for cosine is pi over 2. So if we find the value of x so that this expression is equal to pi over 2, then we know that this will be the cosine of pi over 2, and it'll be 0, and negative 2 times 0 is 0, and 0 plus 3 is 3. So let's add pi over 4 to each side. Let's divide by pi, and I'm getting that when x is equal to 3/4, if you substitute in 3/4, then you'll get the cosine of pi over 2. Now, I know that the center line, the next time that you'll cross the center line is at half of the period, and since this period is 2, half of that is 1, and then if I take that 1 and multiply it by some integer n, then I can just continue going on bouncing from center line to center line, forward or backward. The center line is 3, and with the amplitude of 2, 3 units or 2 units above 3, you'll be at y equals 5, and 2 units below 3, you'll be at y equals 1, and that's the max and min for this function. And let's take a look at where that will occur. If we take the cosine of 0, then I neglected the reflection, so it will not be at 0. It'll actually be the minimum. Okay, so if this expression is equal to 0, then I know I'll be at a minimum because of this negative sign. The graph has been reflected across the x-axis. So I have to think like this. See, the reflection doesn't affect the x-intercepts where we cross the center line, but it will affect the max and the min. So when this is 0, this is actually going to tell me a minimum value. So let's come in and solve for x here. Well, x is equal to 1/4. Now the max and mins are separated not by half a period away, but by a full period at the start of the next cycle. So this will be plus 2n. Now, let's come over and find the max. Not find where the max occurs. Now normally it'd be at 0, but because of this reflection, it's now at pi. So if we add pi over 4 to each side, we'll solve for x here. we'll have 5 pi over 4. Divide both sides by pi, and we'll have 5 over 4. And just like the like the minimum values, the maximum values are separated by a cycle apart, the length of the period. So this will be 2n. Now, it's hard to read my writing there. This should be a 5. Alright, so I hope that helps. Let's go on to the next one. They want us to graph this. Alright, so this negative one is the center line. I want to draw it as let's draw it as a dashed line. With an amplitude of 2, then my maximum value is 2 units above the center line. And my minimum is 2 units below this center line. So my entire graph is bouncing back and forth between y equals -3 and y equals +1. Now, there's a coefficient in front of 1 tells me that the period is 2 pi. There is no shift to the left or to the right, so I'm going to start right here at the center line. See, normally you'd start at the origin, but it's been pushed down 1, and my period is 2 pi, so my pattern, it goes up, comes back to the center line, goes down to the min, comes back up to the center line. So here's what I always refer to as that primary cycle, or fundamental cycle, or first cycle for sine. And this up and down pattern is going to continue on forever to the left and to the right. Alright, so there's my basic shape for this graph. Well, a sketch of the graph for this function. Alright, so again, the +3, my center line is here at 3. The amplitude, the number in front here, the multiplier in front of cosine is 1, so the amplitude is 1. So 1 unit above the center line and 1 unit below the center line are my max and mins. The period, the length of time it takes to complete its cycle is going to be 2 pi, because the coefficient in front of x is 1. So 2 pi, your period is 2 pi divided by b. B is 1, so 2 pi divided by 1 is just 2 pi. Now normally cosine starts at 1, but this minus pi over 2 is actually a shift to the right. So my starting point is going to be here at pi over 2 comma 4. And then the shape of the cosine, it goes down to its center line, it goes to its min, back to its center line, and then it's completed one cycle. So this is a sketch of my first cycle. And if I just continue this pattern forever, to the left and to the right, just bouncing back and forth. Alright, so let's fill in this sketch. There we go. Alright, so there's the sketch of my graph for this function. Okay, so now they give me a function. They want me to describe it. They give me the sketch. Alright, so it's the range is from -2 to +4. And if I add -2 plus 4, I get 2, and half of 2 is 1. So my center line is y equals 1. And if I go up 3 units or down 3 units, I'll be at a max or a min, so the amplitude is 3. Let's say that we start right here and trace out a cycle. If we go up, come down, come back up, we hit that center line a second time there. That's one cycle. The length of this on the x-axis is telling me that the period is pi. The point I picked as a starting point here, because it did want a sine curve and not a cosine curve. We could write a cosine equation for this, but they're not asking us to. The starting point is 0, 1. So let's write our equation. With an amplitude of 3, that's what's the multiplier out in front of the sign. And 2 pi divided by the period, which is pi. There is no shift to the right or to the left. And we did lift the graph. There was a vertical shift of 1 unit. So my equation, these pi's cancel. X minus 0 is just x, so I have 2x plus 1. Alright, so let's move on. Okay, I'll do this in another video on this application problem. Hey, I hope this helps, and I'll talk to you later.